In this section, we're looking at finding particular terms of a binomial expansion. So in section 1, we created the binomial expansion using Pascal's triangle. So now what we're looking for here is, what if we were given a certain term we need to find in the expansion? So what we're saying here is we're expanding the a plus b to the n. Those are binomial expansions. And we kind of had this rule back in the last one where we how we could find our a and b values. Normally they're x and y's, or maybe they're constants, but we started with the high value for a, we worked it decreased, and the b started at 0 and it increased all the way through. Now we also have this combination here, which we've seen before. So what we're saying here is when we look at a term of the expansion where k is 1 less than the number of the term, we're going to use a combination of group n, pick k, to find the coefficient. This gives us the coefficient. And then take that coefficient and find those a and b values in order to write the term. So let's just start working through some practice ones, and we'll see how we can kind of figure it out and how that pattern starts to show up. So find the coefficient of x to the 6th in the expansion of x minus y to the 10th. Alright, so we're looking for x to the 6th. So let's just take this one and kind of work with what we already know. Well, what I already know is if I had a first term, I'm not worried about the coefficient would be. If I had a first term, it would be x to the 10th, right? So the next term would be x to the 9th. The next would be x to the 8th. Then we'd have x to the 7th. And on the 5th term, it would be x to the 6th, because we work our way down. Now, whatever the y is, whatever the coefficient is there, that's great. Right now, we're just using that x to help us, because we know it starts with 10 and it counts down. So that's where x to the 6th shows up. It shows up in the 5th term. Now, what we said back here is k is 1 less than the number of the term. So, if it's the 5th term, we're saying that k equals 1. Not 1 less. It's 4. Now, if we need to now look at what n would be, because remember we just said the, right here, we're looking for that combination. Well, n is the exponent we started with, so that would be 10. So we can write our combination, and we get 10 factorial over 6 factorial 10 minus 6 factorial. And if you remember your combinations, that is actually 10 factorial, 6 factorial, 4 factorial, and whenever we have combinations, those two bottom factorials, the digits should add to the top, which they do here. 6 plus 4 is 10. So if I solve this, 10 times 9 times 8 times 7 times 6 all the way down to 1, well, I have 6 down to 1. That's going to be nice to factor out. 4 times 3 times 2 times 1. Get rid of some of that. Let's see, 4 and 2 are 8. Leaves me with a 3. Take that out of the 9, so I'm left with a 3 up top there. So I have 10, 3, 7. That comes out to be 210. So if I had Pascal's triangle, and I went down to the 11th row, I would have had 11 terms, and gone through there. 210 is one of the terms I would need, that coefficient. Now, we're not done though. We have to make sure it all fits together. So let's say we now know 210 is what the 6th term looks like. Now in that 6th term, it's x, not the 6th term, it's the 5th term. 5th term. It's x to the 6th, and then it would be negative y, well, to what exponent? Well, we talked earlier in the first video that if we knew the total of the two, then we could take that one, help us find the other. So I know it's to the 10th. If it's x to the 6th, then it's going to be negative y to the 4th. So we get 210 x to the 6th, well, negative 4, negative y to the 4th is going to just become a positive, so it's y to the 4th. So we found our coefficient is 210. Okay? Seemed like a lot, but we'll get a little faster with it as we go. So next one, we're looking at x to the 4th when it's x minus y to the 9th. So x minus y to the ninth. Our first term would be x to the ninth. Then we'd go 8, 7, 6, 5, 4. Oh, here we are. So we go second, third, fourth, fifth, sixth term is where we're looking. So we're going to the sixth term. So if it's the sixth term, our k value is 1 less than that, so it's 5, and our n value in the combination is 9. So we're looking for a combination of 9, pick 5, which is 9 factorial over 9, 5 factorial. 9 minus 5 is 4 factorial. So we go 9 times 8 times 7 times 6 times 5. That's going to continue down. We have 5 all the way down to 1, 4, 3, 2, 1. Let's simplify. Take care of the 5's. 4 and 2 are 8. I can take the 3 and 6, make that a 2. So I have 9 times 7 times 2, which turns out to be 126. Okay, now let's piece it all together. We got 126. Then we know it's going to be x to the fourth, because we already counted that up here. Now if it's x to the fourth, it's going to be negative y to the fifth, because 4 and 5 add to 9, and 9 was our original exponent on the binomial. So we're going to simplify it out. We got 126x to the fourth, negative y to the fifth. Since it's an odd with the 5, we keep the negative, we put it out in front, therefore our coefficient is negative 126. So that's why we got to pay attention to that y. Even though that y doesn't have a coefficient out in front, it does have a negative 1, and that could change it so it's a negative value. Okay, let's keep going. So now we're looking at x squared in this. So if we started off, we know our first term would be 3x to the sixth. And we'd keep working our way down. Oops, should be the fifth. 3x to the fourth, 3x to the third, 3x squared. Let's go all the way down to 0, because that actually may help us. Now, we should have 7 of those, which we do. And maybe this is one where it would take us a while to count down. You could always start from the 0 and work your way up, because we know we have 7 terms, so we actually kind of go backwards. But we get third, fourth, fifth is where we're going. So our fifth term, we take 1 less than that is k, and n is 6, because the whole thing is to the sixth. So we go combination of 6, pick 4, gives us 6 factorial over 4 factorial, 2 factorial, which is going to be 6 times 5 times 4 through 1, 4 through 1, and 2 times 1. If we simplify here, looks like I'm left with 15. So 15 is my coefficient. Not my final answer, though, because I have to check. Well, this time definitely if I have 3x and 2y. So what I'm going to do is I'm going to write it out. I'm going to have 15 times 3x squared, then 2y. Now, if it's 3x squared, the exponent for the y term would have to be 4, because 2 and 4 give me 6. So we multiply out, we get 15 times 9x squared, and 2 to the fourth is 16, y to the fourth. So now it's 15 times 9 times 16. Let's multiply that out. Go over here. Let's do 15 times 9 first. We get 135, and then times 16. turns out to be 2,160 x squared y to the fourth, with our coefficient being 2,160. Okay, last one of the find the coefficients. So now it's looking for x to the fourth. We start with 3x to the eighth, 3x to the seventh, 3x to the sixth, 3x to the fifth, and 3x to the fourth. So we want 1, 2, 3, 4, 5. Fifth term, one less, so k is 4, n is 8, because that's our exponent. We're going to do a combination of 8, pick 4. That's 8 factorial over 4 factorial, 4 factorial. 8 times 7 times 6 times 5 times 4 through 1. 4 times 3 times 2 times 1 times 4 through 1. We can simplify here. 4 and 2 give us 8. Looks like the 3 and 6 give us a 2 left up there. So I have 7 times 2 times 5, which gives me 70. So that's our lead term, 70, our lead coefficient. Then it's going to be 3x to the fourth. And then if x is to the fourth, that means y would be to the fourth because it adds to 8. We get 70 times 3 to the fourth, which is 81. X to the fourth, y to the fourth, and now 70 times 81 is 5,670, x to the fourth, y to the fourth. And our coefficient is 5,670. Now, we could carry this on. We really could find any term. It's just that process that if I give you some term, some exponent really for x, you can go through that process. You can find which term we want. It gives you a k value. You can find your combination, and then you use that to piece together your whole term with your x value and your y value, and you'd be there. So now we're going to go to a different approach. Now we're asking for a specific term in our binomial. So now I'm asking for the second term. So I could write like I did before, first term, second term, and find to where it is. And this one would be a to the 8th, a to the 7th. But what we did already is we said, okay, once we get to that, our k value is 1 less. So for this one, since it's the second term, we're going to say that k is 1. We've already talked about earlier, n would be 8, because that's our exponent. So now it's going to be a combination of 8, pick 1, and I get 8 factorial over 1 factorial, 7 factorial. Now this comes out to be 8. Now, that's our coefficient. So we have a and b. Now, earlier on, we said right here that a to the n minus k, b to the k. Let's look at that again. So we're saying that to write our term, we do a, not equals, a to the n minus k, b to the k. So we'll take two approaches. So let's go through this. I know this is a to the 7th because it's the second term, and I would have started with a to the 8th and went to a to the 7th. Okay? Now, if that's to the 7th, that means b is to the first because they have to add 8. But if we look at this rule we've actually defined earlier, if I know my k value, I know my b's exponent, which k is 1, that matches. Then my exponent on a would be 8 minus 1 in that case, which also gave me 7. So that would give us another way to get to it. So we actually can say 8, a to the 7th, b to the 1st. Now, let's pick a different one and see if that actually helps us, because this rule could save us some time from having to write out a lot of stuff. So I'm looking for the 7th term. 7th term means I'm going to take 1 less. So k is 6, n is 9. So it's a combination of 9, pick 6. That gives me 9 factorial over 6 factorial, 3 factorial. We get 9 times 8 times 7 times 6 through 1. We could do 6 through 1 times 3 times 2 times 1. We could do 2 and 8 leave us with a 4 on top. 3 and 9 leave us with a 3 on top. 3 times 4 times 7. Let's see, we get 28 times 3. Let's do it down here. We get 84. So, we have 84, and now we have C and negative D. So I could count my 7th term down and figure out what my exponent is. Kind of the same idea we just did in the first set of examples. But I know my exponent here is the same as my k value. So that's 6. And then my exponent here is n minus k, which would be 3. Well, okay, so far so good. That adds up to be 9. You know, since it's the first time, let's double check. So let's see, my first term would be c to the 9th. Then I'd go 8, 7, 6, 5, 4, 3, 2, 1. So I have first, second, third, fourth, fifth, sixth, 7th term is 3. So it actually worked in that case too. So we could actually use that rule there to help us out. So let's finish up simplifying. I get 84, c to the 3rd, and then since 6 is even, it's a positive, d to the 6th, and here is my answer for that term. Okay, so let's keep going. Now it's the second term of x plus 3y to the 10th. So we said earlier our combination of n, pick k, a to the n minus k, b to the k. Now, how we find k? Well, it's 1 less than our term. So k is 1. N is our exponent, 10. So combination of 10, pick 1, give me 10 factorial over 1 factorial, 9 factorial, which comes out to be 10. Now that's going to be x to the power and 3y to a power. So my exponent on y is k, that's 1. My exponent on x is 10 minus 1, 9. So we get 10 x to the 9th times 3y. We get 30 x to the 9th y. Little bit faster than counting out all our terms, but we could go through and just double check because it's a new process. Let's think. First term would be x to the 10th. Second term would be x to the 9th because we count down. Okay, it fits. We should be good. Okay, next we go 5th term of 3x minus 2y to the 9th. So k equals 4, 1 less, n equals 9. So we're going to go combination of 9, pick 4, gives us 9 factorial over 5 factorial, 4 factorial, 9 times 8 times 7 times 6 times 5 all the way to 1. 5 through 1, 4 times 3 times 2 times 1. Simplify 4 and 2, give me 8. We can go cross out the 5 down. 6 and 3 leave me with 2. So I have 9 times 7 times 2, which gives me 126. So we get 126. Then it's going to be 3x and negative 2y. My exponent for the y term is going to be 4, because that's k. My exponent for the x is 9 minus 4 is 5. Looks like we're going to have to piece this one together. We get 126, so we have 3x to the 5th is 243 x to the 5th, and the negative 2y to the 4th is 16y to the 4th. We're going to have to multiply these all together. We're going to bring in the use of our calculator for this one. So we have 126 times 243 times 16. Get a rather large term here. That's 489,888 x to the 5th y to the fourth.